Topic 1.4, Graphing Logarithms. We're going to be covering transformations, reflections, and graphing the logarithm function. So here are some timestamps. Now let's look at the graph of the logarithm function. This is what the base function looks like. Now, right off the bat, it looks pretty interesting. There's a domain restriction, but there's not a range restriction, which is an inverse of what the restrictions on the graph of the exponential function looks like. And that's true, because the logarithmic function is the inverse of the exponential function. We can also reflect it by taking a negative operator of x onto the y-axis. We can reflect on the x-axis by writing as negative log, which can also be interpreted as y equals log 1 over x. That is one interpretation we can work with. Now, we can also transform the logarithmic function. There are also horizontal and vertical transformations we can consider. For example, for horizontal transformations, a negative will actually mean it goes to the right, and a positive onto the x is actually going to go to the left. And the opposite is true for vertical transformations. A positive will go up, a negative will go down. Pretty intuitive. You already learned this in functions. Now, let's sketch the inverse of these functions. At first, it might look a bit complicated, but hear me out, it's not that bad. Let's first take the inverse, which we know we can derive from swapping the x's and y's. We can derive our logarithm. We know this is our logarithm, we know this is our base, and this is our anti-logarithm. So we can write y equals log 4 of x. Let's make our xy table to graph. Now, let's think about when y equals 0. Let's find when y equals 0. Well, in order to find this x-intercept, we can just plug in y equals 0 here. When y equals 0 here, x is actually just going to be 1. 4 to the power 0 is just 1. We can also find other critical points that we believe are useful. For example, if y is 1, we know x is 4. And we know if y is 2, x is going to be 16. So now we have a few points that we can just plot. And we can make our logarithmic function based on it. Now, let's do this for this. This will have a different base or anti-logarithm based on how you do it. However, for this, I'll show you how I would do it. I would write it as so. It's going to be 3 negative x. If we were to swap, we would get negative x equals 3 to the y, such that y is actually just going to be log 3 negative x. Now let's make our xy tables. And we realize this is reflected on the y-axis because there's a negative anti-logarithm for the x, which is pretty interesting. So let's do something similar again. I would prefer starting out with y equals 0 as a good point. Let's say y is 0. We know that x is also just going to be negative 1. When y is 1, x will be negative 3. And y is 2, x is going to be negative 9. So let's plot our points. This is going to be 2. This is going to be 1. And this means 0. And there we have it. This is a basic way to really just understand how to graph logarithms.